Chapter 7 Triangles. First exercise. In quadrilateral ACBD, AC equal to AD and AB bisects angle A. Show that triangle ABC congruent to ABD. So we can consider these two triangles. Consider triangle ABC and triangle ABD. In these two triangles, we can write AC is equal to AD. AC is equal to AD. That is given. Then AB is equal to AB. Common side. Common side for both the triangles. And angle. Here CAB. Angle CAB is equal to angle DAB. These two angles are equal. Angle CAB is equal to angle DAB. Reason is AB. Here it's given. AB bisects angle A. AB bisects angle A. Now we got three conditions. AC is equal to AD, AB is common, and these two angles are equal. So we can write, therefore, triangle ABC is congruent to triangle ABD by SAS congruency. SAS congruency. So we proved that these two are congruent. Now next is BC and BD. BC and BD. So we can write here BC is equal to BD by CPCT. CPCT. Corresponding parts of the congruent triangles. In this triangle BC and BD is coming the same way. That means corresponding parts of the congruent triangles. By CPCT, that is, these two are equal. Second question, ABCD is a quadrilateral in which AD is equal to BC and angle DAB is equal to CBA. Prove that triangle ABD is congruent to BAC, these two triangles. So first we have to consider these two triangles. Here we can see AB is common in both the triangle, in this triangle and here. So AB is equal to BA. Here we can write AB is equal to BA, first two letters. AB is equal to BA, common side for both the triangles. And here the angles are given. Angle A is equal to angle B. Here it is given that angle DAB is equal to CBA. So that we can write. So here the given angles that we can write, angle DAB is equal to CBA, which means these two angles. And also AD is equal to BC. That also given. From that we can write three conditions already we got. So we can write, therefore, triangle ABD is congruent to triangle BAC by SAS, two sides and one angle. SAS congruency. So this by using SAS congruency. Then next BD is equal to AC. BD is equal to AC, that is coming CPCT. If once we proved that one, then the corresponding parts, which implies BD is equal to AC, CPCT. Then angle ABD. ABD is equal to angle BAC. Here that also is coming CPCT. We already proved that triangle ABD congruent to triangle BAC. Then the same angle Angle ABD is equal to angle BAC, that means CPCT. Corresponding parts of the congruent triangles. Third question. AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. For that, first we have to consider these two triangles. Triangle AOD and triangle BOC. In these two triangles, here it's given AD and BC. AD and BC are equal. So we can write AD here. AD is equal to BC, that is given. Also, angle A is equal to angle B is equal to 90 degree. Angle A is equal to angle B, and that is equal to 90 degree. That also given in the question. Now we can consider this angle. These two angles are vertically opposite angles. So we can write that one. Angle AOD, angle AOD is equal to angle BOC. BOC. Reason is vertically opposite angles are equal. Vertically opposite angles. So we got three conditions. Two angles and one side. So we can write, therefore, triangle AOD is congruent to triangle BOC by AA congruency rule. AA congruency, these two triangles are congruent. Then in this we can see OA is equal to OB, which implies OA is equal to OB, CPCT. If these two triangles are congruent, its corresponding parts are equal. So OA is equal to OB by CPCT, which means CD bisects AB. So we can write that is CD bisects AB. Hence proved. So first we had to find the criteria by suitable criteria. These two triangles are congruent. After that, the corresponding parts are equal. So here OA is equal to OB, which means CD bisects AB. Fourth question. Here L and M are parallel lines. So given that, we can write given that is L, M are two parallel lines and intersected by another pair of parallel lines P and Q. Show that. Then we have to prove this one. Triangle ABC, which means this triangle and CDA. These two triangles are congruent. So first we have to write what is given. L and M are two parallel lines and also P and Q are the parallel lines. Then to prove, that is triangle ABC congruent to triangle CDA. Then proof. So here we can write given first step, given that P parallel to Q and L parallel to M. These two lines are parallel. These two lines are parallel. Then to prove, given to prove, then proof. So we have to prove ABC, triangle ABC congruent to triangle CDA. Then proof. Consider these two triangles ABC and CDA. Then we have to write the conditions. First one, angle BCA. BCA means these two angles are equal. BCA is equal to DAC. Alternate interior angles. These two lines are parallel. So these two angles are alternate interior angles and they are equal. Similarly, these two angles. These two angles. BAC equal to DCA. That also alternate interior angles. Then we can write AC is equal to CA. This side is common to both the triangles. So we can write third condition, AC is equal to CA, that is common side. So by using these three conditions we can write, therefore triangle ABC is congruent to triangle CDA. Here two angles and one side. So ASA congruency. So we proved that, hence proved. Question it was, these two triangles are congruent to prove. So by these three conditions, using ASA congruency criteria, we can write these two triangles are congruent. Fifth question, L is the bisector of an angle A. So it is given. We can write given, same sentence. L is the angle bisector of angle A, and then is the point L and BP, BQ are the perpendiculars. Also it's given that angle P is equal to angle Q, which is equal to 90 degree perpendiculars. Now we have to prove this one, to prove that. So we can, first we have to consider these triangles, triangle APB and triangle AQB. In triangle APB and triangle AQB, that means APB, this triangle, AQB, this one. These two triangles, when we are comparing, we can write here angle P is equal to angle Q, that is equal to 90 degree, it's given. Then AB is common to both the triangles. This line segment AB is common to both the triangles. So AB is equal to AB, that is common side. Then we have to consider this angle, these two angles. That one, this line L is the angle bisector. So we can write here BAP, angle BAP is equal to angle BAQ. So angle BAP is equal to angle BAQ. L is the angle bisector. L is the angle bisector, or L is the bisector of angle A. Bisector of angle A. Now we got three conditions. Two angles, these two angles and the this side as common. So by these three conditions we can write these two triangles are congruent. So we can write which is congruent by ASA criteria. Here ASA is coming, this one angle and these two angles are corresponding angles are equal. Then automatically the third angle also will be equal. So which means all three angles are equal and one side is common to that. So we can use that ASA here. Then second part, this is the first part. Second part, here BP is equal to BP is equal to BQ. BP is equal to BQ, that is CPCT. Corresponding parts of the congruent triangles. Question number 6 here. AC is equal to AE. AC is equal to AE. AB is equal to AD. And angle BAD is equal to EAC. These two angles. Show that BC is equal to DE. So first we can write the given terms. AC is equal to AE, AB is equal to AD and angle BAD is equal to EAC. Then to prove, BC is equal to DE. Then prove. For that proof, we know that here given that angle BAD is equal to angle EAC. Then by adding CAD on both sides, CAD or DAC, this part we are adding on both. By adding angle DAC on both sides. It's equation number 1 of equation 1. Then we will get that as here angle BAD plus angle DAC is equal to angle EAC plus angle DAC. Now we added angle DAC on both the sides. Then we are looking BAD plus DAC, it will become BAC. So we can write angle, that is angle BAC is equal to, same way here also, CAE plus DAC, that will become EAD till here, angle EAD. So when we are adding angle BAC, that means from here till there and this one from EAC are equal. Now consider triangle ABC till here, this full, and ADE from here to here. In that we can see AB is equal to, from the term itself, AB is equal to AD, and AC, first and third letter, AC is equal to AE. Here also in the figure, AC is equal to AE, and this angle also are equal. So by SAS congruency, we can say these two triangles are congruent. Therefore, BC is equal to DE, corresponding sides. Question number 7 here. AB is the line segment and P is the midpoint. D and E are the points on the same side of AB such that BAD, angle BAD is equal to angle ABE. These two angles are equal, and also these two angles are equal. Show that triangle DAP till here, which is equal to triangle EBP, these two triangles. For that, first we can write the given terms. P is the midpoint of line segment AB, and these two angles are equal. Then first part, here it is given that angle EPA is equal to DPB. Now we are going to add angle DPE on both sides. DPE, this part on both sides. So here it will add angle DPE on both sides. This we can mark as equation 1. Then that one will come as angle EPA plus angle DPE, and that is equal to angle DPB plus angle DPE, which means, so when we are adding this part with that, we will get DE here, DPA till this full is equal to EPB. We got that when we are adding this common part to both the sides. And also we can write AP is equal to BP. AP is equal to BP. P is the midpoint. Point of AB, that is given. Again, This is the first condition. Now this is the second condition. This is the first condition, second condition. Now one more condition, that is here given, this angle, these two angles, which means BAD. BAD, angle BAD is equal to this BAD is equal to angle ABE, that is given. Now by using these three conditions we can write triangle DAP is congruent to triangle EBP by ASA congruency, two angles and one side. So ASA congruency, we can write these two triangles are congruent. That's the first part. Then AD is equal to BE. Second part, AD is equal to BE, that is CPCT. Now question number 8. In a right triangle ABC, right angle at C. So we can mark this angle as 90 degree. M is the midpoint of the hypotenuse AB. M is the midpoint of AB. That means AM is equal to BM. Then C is joined to M and produced to D such that DM is equal to CM. So this also equal. DM is equal to CM. And point D is joined to point B. Then show that triangle AMC, which means this triangle, and BMD are equal. So we have to prove these two triangles are congruent. Here itself we can say directly these two sides are equal. Same way second option, so these two sides are equal and vertically opposite angles are equal. So by side angle side congruency we can write these two triangles are congruent. So the three conditions, first it is here AM is equal to BM, these two triangles when we are considering. Then CM is equal to DM and these two angles are vertically opposite angles. So three conditions there. By using these three conditions we can write these two triangles. Therefore triangle AMC is congruent to triangle BMD. Two sides and one angle, which means SAS. SAS congruency criteria. So first part is over. Now second part, triangle DBC. DBC is right angle. For that, from here we can write angle ACM, which means this angle is equal to angle BDM. These two angles are equal. From these two triangles are congruent, by CPCT these two angles are equal. If these two angles are equal, we can say these two lines are parallel. That means AC parallel to BD. These are the alternate interior angles. If alternate interior angles are equal, then next we can write AC parallel to BD. Reason is alternate interior angles are equal. If these two lines are parallel, then we can write angle C plus angle B is equal to 180 degree, which implies angle C plus angle B is equal to 180 degree. The reason is co-interior angles. Co-interior angles, which means these two are parallel and this is the same side of the transversal. So co-interior angles. Here already angle C is 90 degree, that is given. Right angle at C, that is given. So we can put that is 90 degree plus angle B is equal to 180 degree, which implies angle B is equal to 90 degree. That's the second part, which means angle B means DBC, angle DBC. That is, angle DBC is a right angle. That is the second part. Now the third part of the question. Prove that triangle DBC. So consider that one. Consider triangle DBC and triangle ACB. Triangle ACB. Here we can write BC is the common side in these two triangles. One is this triangle, the other one is here. So BC is common. So we can write first condition. Here BC is equal to BC. That means common side. Then angle B is equal to angle C. Angle B, this angle is equal to angle C. Angle C, that is equal to 90 degree. Now we proved that here. Then third part here, BD is equal to AC. These two sides are equal by CPCT of the first proof. BD is equal to AC by CPCT. Now three conditions we got. One is the common side. This side, both the sides are equal, and the angle. So we can write therefore triangle DBC is congruent to triangle ACB by SAS, two sides and one angle. Now the fourth part, CM is equal to half of AB. From here we can write these two triangles are congruent. Then DC is equal to AB. That means CPCT. DC is equal to AB. That we are applying here. DC is equal to AB, CPCT of this third part, which one we already proved. Then we know that DC means DM plus CM, which implies DM plus CM, and AB we can write as AM plus BM. AM plus BM. M is the midpoint. M is the midpoint. That's the reason what we are writing here. Then also we know that all these are DM is equal to CM and AM is equal to BM. So all these four measurements are equal. So we can write in place of CM, 2CM is equal to AM plus BM, that is AB. Here the reason is DM is equal to CM, which is equal to AM, which is equal to BM. All four parts are equal. So we can combine this. DM plus CM is same as 2 times CM. DM is equal to CM, which is equal to AB, which implies CM is equal to half of AB. Exercise 7.2, first question. In an isosceles triangle ABC, AB is equal to AC. That means these two sides are equal. And the bisectors of angle B and angle C intersect at O. Join A to O. Then first part, prove that OB is equal to OC. So first we can write the given terms. AB is equal to AC and bisectors of angle B and angle C intersect at O. From the first part, AB is equal to AC. These two sides are equal, which means these angles are also equal. Equal opposite angles of equal sides. So we can write that. So we can write angle B is equal to angle C. Angles opposite to equal sides are equal. So base angles are equal. From that, if we are taking half of that angle, half of angle B is equal to half of angle C. That also here given angle bisector. Angle B and angle C are bisectors of that. So we can write the reason as angle bisectors. This half of angle B, that means we can take this part. And half of angle C means this one. So which implies angle OBC is equal to angle OCB. These two angles are equal by using the angle bisectors, which implies, or therefore we can write, if these two angles are equal, these two sides are equal. Same way, sides opposite equal angles. Therefore, in triangle OBC, OB is equal to OC. Reason is angle OBC is equal to angle OCB, then sides opposite to equal angles are equal. These two angles are equal, then sides opposite to equal angles are equal. These two sides are equal. So that means we can write OB is equal to OC. That's the first part. Now the second part, AO bisects angle A. To prove the second part, in triangle AOB, this triangle and AOC, these two triangles we have to consider. In these two triangles, we can write first point OA is equal to AO, or AO is equal to AO, that is common side. Then AB is equal to AC, that is given. It's given in the question. Then next one, OB is equal to OC. We proved in part 1. So 3 conditions we got now. By using these 3 conditions, we can write triangle AOB and triangle AOC are congruent by SSS congruency. These two sides are equal, these two are equal, this is the common side. And therefore, we can write angle BAO. This angle BAO is equal to angle CAO by CPCT, which means angle A bisecting, or AO bisects angle A. This line bisecting angle A. So here first we proved these two triangles are equal, and then these two angles are by CPCT, these two are equal. If these two angles are equal, which means OA bisects angle A. That's the second part. Second question. Here in triangle ABC, AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle with AB is equal to AC. So we can write first given terms. Here given that AD is the perpendicular bisector. AD is the perpendicular bisector of BC, and to prove AB is equal to AC. So here we can write given that AD is the perpendicular bisector of BC, and to prove AB is equal to AC. For that proof, Here in this figure, we know that this is 90 degree, the other side also 90 degree. Now we are considering these two triangles, triangle ADB and triangle ADC. And we can write these two angles are equal. That means 90 degree. So we can write in these two triangle, angle ADB is equal to angle ADC. That is equal to 90 degree. Then second condition, AD is equal to AD. This AD is common for both the triangles. AD is equal to AD, common side. Then again, DB is equal to DC. DB is equal to DC. Here it is given AD is the perpendicular bisector of BC. Bisecting, equally dividing. That means DB is equal to DC. D is the bisector. Of BC. Here AD is the bisector of BC. So three conditions. First one is these two angles are equal. Then this is the common side. Then these two sides are equal because AD is the perpendicular bisector of BC. Now side, angle, side. Using SAS, we can write therefore these two triangles. Triangle ADB congruent to triangle ADC by SAS. Two sides and one angle. SAS. If these two triangles are congruent, then we can write AB is equal to AC, which implies AB is equal to AC by CPCT. So hence proved. That's the proof of the second question. Third question, in triangle ABC is an isosceles triangle in which altitudes BE and CF are drawn equal sides AC and AB. That means AC and AB are equal. Show that these altitudes are equal. So here it is given that AB is equal to AC. So that we can write it here, AB is equal to AC, that is given. Now we are considering these two triangles, triangle AEB and AFC, these two triangles. In these two triangles, AB is equal to AC, that is given. Then we can write angle A is equal to angle A, common for both the triangles. Common angle. Then one more condition, we can take this one. Angle AEB, angle E is equal to angle F. You can write in three-letter form. Angle E, that means AEB is equal to AFC, which is 90 degree, it's given. So three conditions. AB is equal to AC, angle A is common for both the triangles, AEB is equal to AFC, 90 degree. Therefore, we can write triangle AEB is congruent to triangle AFC by two angles and one side, AAS criteria. So, these two triangles are congruent, which implies here BE is equal to CF. BE is equal to CF. That means by CPCT. By CPCT, BE is equal to this, all BE and CF are the altitudes. So we proved that the altitudes are equal. And right, that is the altitudes are equal. Question number 4. ABC is a triangle in which the altitudes B, E and CF, two sides AB and AC and AB are equal. That means these altitudes are equal. It's given. So we can write given that BE is equal to CF. These two are equal. Then we had to prove triangle ABE congruent to triangle ACF. So first we have to consider proof. Consider triangle ABE and triangle ACF. Three conditions we need. First one, we can write here what is given. BE is equal to CF. BE is equal to CF, that is given. Second condition, angle A is common for both the triangles. Angle A is equal to angle A, common angle. That is for both the conditions. Now we need third condition. Third condition, that is, here these two are 90 degree. That also it's given, that we can write. So two parts, and the third part is by three letter form. Angle AEB, this angle. Angle AEB and angle AFC, this angle. These two are 90 degree, that is given here. Perpendiculars. So two angles and one side. Using these three conditions, we can write triangle ABE congruent to triangle ACF. That means by AAS condition. Two angles and one side. Then therefore to prove the second part, from here we can write AB is equal to AC. AB is equal to AC, CPCT. So that's the second part. If AB is equal to AC, then ABC is an isosceles triangle. Therefore, triangle ABC is an isosceles triangle. So that is the proof. Fifth question, ABC and DBC are two isosceles triangle. Show that these two angles are equal. So we can write given that these two are two isosceles triangle, and to prove that one. Then for the proof, consider these two triangles ABD and ACD. Consider triangle ABD and triangle ACD. You have to take these two triangles. In that AB is equal to AC. First condition, AB is equal to AC. Reason, ABC is an isosceles triangle. ABC is isosceles. Isosceles triangle, therefore AB is equal to AC. Same way here, DB is equal to DC. That's the reason triangle DBC, this triangle. Is isosceles. And now AD is common for both the triangles. AD is equal to AD, common side. Now three conditions we got. Equal in these two triangles. So we can write therefore these two triangles are congruent. That means triangle ABD is congruent to triangle ACD by using here three sides what we have taken. So SS is congruency. these two triangles are equal. Then we can write these angles, which implies angle ABD. ABD is equal to angle ACD by CPCT. In question number 6, triangle ABC is an isosceles triangle. That means AB is equal to AC. Then BA produced such that AD is equal to AB. Then show that triangle BCD is a right angle. That we can do it here, sixth one answer. Here we can mark this angle as angle 1, this is 2, this one 3, here 4. And what is here given? AB is equal to AC. AB is equal to AC given, which implies base angles. Angle 1 is equal to angle 2. Angles opposite equal sides. So that we can mark as equation 1. Then again here it is given AD is equal to AB. AD is equal to AB. AD is equal to AB, that also given. From that we can write, we already know that AB is equal to AC, that is AB, AC, AD, everything is equal. AB is equal to AC is equal to AD. From that we can take this one, AC is equal to AD, these two, which implies AC is equal to AD. If AC is equal to AD, then angle 3 is equal to angle 4, base angles. In this triangle, AC is equal to AD, which means its base angles are equal. Therefore, angle 3 is equal to angle 4. Base angles of this triangle. Angles opposite to equal sides. So that we can mark as second equation. Now in triangle DBC or DCB, if we are considering in triangle DCB, we know that angle B plus angle C plus angle D is equal to 180 degree. Angle B plus angle C plus angle D is equal to 180 degree angle sum property. Now angle B is 1 plus angle C is 2 plus 3. Angle C 2 plus 3, then angle 4 is equal to 180 degree. Now we know that is from 1 is equal to 2, so we can replace that. In place of angle 1, that is angle 2 plus already this angle 2 plus in place of angle 4, angle 3 is there. In place of angle 4, we can write angle 3 is equal to 180 degree by equation number 1 and 2. That means 2 times of angle 2 plus angle 3 is equal to 180 degree, which implies angle 2 plus angle 3 is equal to 180 by 2, 90 degree. Angle 2 plus angle 3 means angle C. That is angle C is equal to 90 degree. So here to prove that BCD, therefore we can write angle BCD is equal to 90 degree right angle. Or angle BCD is a right angle. Question number 7. ABC is a right angle triangle with angle A is 90 degree and AB is equal to AC. Find angle B and angle C. So here in triangle ABC, angle A is equal to 90 degree and AB is equal to AC. If AB is equal to AC, which implies its base angles are equal. Angle B is equal to angle C. If these two sides are equal, its base angles, these two will be equal. Angles opposite to equal sides. Angles opposite to equal sides. Then, therefore, in triangle ABC, we can write angle A plus, therefore no need. In triangle ABC, we know that angle A plus angle B plus angle C is equal to 180 degree by angle sum property. Now here angle A is 90 degree plus angle B plus in place of angle C also we can write as angle B. Both the angles are equal. So angle B is equal to 180 degree. That is 90 degree plus 2 times angle B is equal to 180 degree, which implies 2 angle B is equal to 180 minus 90 is equal to 90 degree. From that is angle B is equal to 90 by 2 is equal to 45 degree, and that is equal to angle C. Here already we have written that as angle B is equal to angle C. So we got that. Therefore, angle B is equal to angle C is equal to 45 degree. Eighth question. Show that the angles of an equilateral triangle are 60 degree each. You can take a triangle ABC is an equilateral triangle. Equilateral triangle means all three sides are equal. If all three sides are equal, then all the three angles are also equal. If these two sides are equal, its base angles are equal. These two are equal, these base angles are. So which means all three angles are equal. So in an equilateral triangle, ABC, we know that AB is equal to BC is equal to AC, which implies angle A is equal to angle B is equal to angle C. Or equilateral means all sides are equal. So angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Therefore, all angles are equal. Then in triangle ABC, angle A plus angle B plus angle C is equal to 180 degree. That means angle sum property, which implies here all these three angles are equal. So we can take angle A as angle B plus angle B plus angle B is equal to 180 degree, which implies 3 times angle B is equal to 180 degree, and that means angle B is equal to 180 by 3 is equal to 60 degree, which means all three angles are equal. That means angle A is equal to angle B is equal to angle C is equal to 60 degree. So we can write all the three angles. Angle A is equal to B is equal to C is equal to each one with 60 degree. That means the angles of an equilateral triangle are 60 degree each. Exercise 7.3. First question. In triangle ABC and DBC are two isosceles triangles. That means ABC and DBC. On the same base, BC and A and D are on the same line, and AD extends to intersect BC at P. First part, prove that triangle ABD congruent to triangle ACD. That means ABD. These two triangles are congruent. That we have to prove. First part. It's given triangle ABC and DBC are isosceles triangle. So consider these two triangles. Consider triangle ABD and triangle ACD. In this we can write AB is equal to AC. AB is equal to AC. Reason is triangle ABC is isosceles. So these two sides are equal. Same way BD is equal to CD. Reason triangle DBC is isosceles. Now this AD is common for both the triangles. So AD is equal to AD, that is common side. Now three conditions. All three sides are equal. These two sides are equal because ABC is isosceles triangle. These two sides are equal. Triangle BDC or DBC is isosceles and AD is common. So we can write therefore triangle ABD is congruent to triangle ACD by SSS. All three sides. SSS congruency criteria. From that we can take the CPCT. These two angles are equal. So we can write that as angle DAB is equal to angle DAC. That is CPCT, corresponding parts of the congruent triangle. Now the second part, we have to prove triangle ABP. That means ABP, this triangle. ABP congruent to ACP. These two triangles congruent. There also we can write these two sides are equal and AP is common and these two angles are equal. Then S side, angle side, SAS congruency condition. These two triangles are congruent. Now third part, to prove AP bisects angle A and angle D. For that, first we have to prove these two triangles are congruent. So we can take these two triangles. In these two triangles, we have to consider triangle BPD and CPD. These two triangles. Here we can write BD is equal to CD because DBS is an isosceles triangle. These two sides are equal. Then PD is equal to PD. In both the triangle, PD is common side. Then BP is equal to CP. This already we proved here in the second part. So we can mark that as equation number 2. Already proved in second part and CPCT of that. This one. We proved these two triangles are equal. So the corresponding parts BP is equal to CP. That here we are using. So all three sides are equal. So by SSS congruency criteria, we can write triangle BPD congruent to triangle CPD. If these two triangles are congruent, then we can write the corresponding angle PDB, this angle. These two angles are equal by CPCT. Same way in the first proof, already we have written there these two. DAC is equal to DAB. These two angles are equal. Now from 1 and 3 we can write AP bisects angle A and angle D. This line segment bisects angle A and angle D. So the third part is proved. Now the fourth part of that question, we have to prove AP perpendicular to BC. For that, from here, the third part we can write angle BPD. This angle is equal to CPD. So angle BPD is equal to angle CPD, that is the CPCT of third part. Again, BP is equal to CP, that is the CPCT of second part. So these two angles are equal and these two sides are equal. So we can write that is angle BPD plus angle CPD is equal to 180 degree because BC is a straight line. Which means these two angles are equal. From that we can write as, which implies 2 times BPD is equal to, angle BPD is equal to 180, because in place of CPD from here, BPD is equal to CPD. So in place of angle CPD, we are replacing by angle BPD. So 2 times of that is equal to 180, which implies angle BPD is equal to 180 by 2. It's equal to 90 degree. So we got this angle BPD is equal to 90 degree, which implies angle CPD also 90 degree. This angle is 90 degree. Therefore, we can write AP is the perpendicular bisector of BC. Second question, AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. Show that first part AD bisects BC. So here it is given AD is the altitude, that means perpendicular 90 degree, and isosceles triangle with AB is equal to AC, that is given. Now consider these two triangles, triangle ABD and triangle ACD. There we can write AB is equal to AC given. Isosceles triangle, that is given, AB is equal to AC. And angle BDA is equal to CDA. Angle BDA is equal to angle CDA 90 degree, that also given. Then AD is equal to AD, that is common side. So we can write therefore 3 conditions. Triangle ABD is congruent to triangle ACD by RHS. Congruence criteria 90 degree, common side and hypotenuse. From that, if these two triangles are congruent, then we can write these two sides are equal by CPCT. So which implies BD is equal to CD, CPCT. Which means AD bisects BC, that is AD bisects BC. Now the second part, AD bisects angle A. If these two triangles are congruent, already we proved here in one. So we are writing once more. These two triangles are congruent, already proved. From that we can take BAD. This angle is equal to CAD. These two angles are equal by CPCT, which means AD bisects angle A. Hence proved. Now third question. Two sides of AB, BC and median AM of the triangle ABC respectively equal to PQ, QR and PN of the triangle PQR. Then prove that triangle ABM, that means this triangle ABM is congruent to triangle PQN. Here we can write the given terms. AB is equal to PQ, BC is equal to QR, AM is equal to PN. And first part we have to prove these two triangles are congruent. For that, the given terms we can take AB is equal to PQ, that is given. AM is equal to PN, that also given, medians. Then BC is equal to QR. BC is equal to QR. But here we are taking half of that BC. AM is the median. Median means M is the midpoint. So half of BC we can write, which is equal to half of QR, which implies half of BC is BM. BM is equal to half of QR is QN. Now we got all three sides as equal. So we can write, therefore, triangle ABM is congruent to triangle PQN. ABM congruent to triangle PQN by SSS. Now for the second part of that question, triangle ABC congruent to triangle PQR. For that, from here already we proved that these two triangles are congruent. From that we can write angle B is equal to angle Q. That is CPCT. Angle B is equal to angle Q, CPCT, corresponding parts. These two triangles are congruent, then angle B is equal to angle Q. That we are applying here. Now we are considering triangle ABC and triangle PQR. There also AB is equal to PQ, that is given. Then BC is equal to QR, that also given. And angle B is equal to angle Q, that is CPCT from the first part. Then by using these three, triangle ABC congruent to triangle PQR by SAS congruency. Side, angle, side. Congruency, that is the second part. That means ABC congruent to triangle PQR. So we can write hence proved. Question number 4. BE and CF are two equal altitudes. BE and CF, these two are equal altitudes of triangle ABC. Using RHS congruence rule, prove that the triangles ABC is isosceles. So here we can consider triangle BEC and CFB, these two triangles. Here we can see angle FBFC is equal to CEB, this altitudes given. BC is a common side for both the triangles and BE is equal to CF. These two are equal altitudes. It's given in the question, equal altitudes. Equal means BE is equal to CF and altitude, that means these two angles are 90 degree. Then BC is the common side. BC is equal to CB. So by using these three RHS congruence criteria, we can write these two triangles are congruent. If these two triangles are congruent, from there we can write angle B is equal to angle C, CPCT. If angle B is equal to angle C, then AB is equal to AC, opposite sides of equal angles. AB is equal to AC, which means triangle ABC is isosceles triangle. Now fifth question, in triangle ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular, that means 90 degree to BC. Show that angle B is equal to angle C. For that, first we have to consider these two triangles. Here AB is equal to AC, that is given. AP is the common side for both the triangles, and angle APB is equal to APC, this 90 degree, that also given. AP is perpendicular to BC, it is given here. So using that, by RHS congruence criteria, we can write these two triangles are congruent. If these two triangles are congruent, then we can write angle B is equal to angle C, CPCT. So hence proved.